Welcome to another video tutorial series. In this video tutorial, we will be doing this research question with a live example using SPSS and live writing in a BA 7th edition, interpretation of statistical findings, suggestion of statistical test relevant to this problem, and why did we choose the particular test. We will explain the reason and also the assumptions that we will be checking. So the question is, uh, before going to the full video tutorial, I would like to request, if you haven't subscribed to our channel, please subscribe and follow so that new updates will reach to you. So the research question is there a difference in the number of blood tests between patients who had comorbidity and those who did not? So to answer these questions one by one based on this um, task, this research question, I will be using Word document. H naught in this case would be H naught. H naught in this case would be there is no difference at mean level between of the number of blood tests between the group comorbidity and not comorbidity. The purpose is that basically we have two groups, that is the patients having comorbidity and the patient without comorbidity. So this is the null hypothesis. What is the alternate hypothesis? That would be there is a difference at mean level of the number of blood tests of the patients between the group of patients having comorbidity or not comorbidity. So what test did you use to investigate whether this so comorbidity, that is this variable, and if we check its values, so it has no NS, so basically binary responses. So in case of binary response, we will be using, and obviously the second variable, the testing variable, is uh, blood test, this one, number of blood tests. So if we check the blood test in the variable section, it shows us that it is the number, like it's a numerical variable. So obviously we shall suggest independent hypothesis. Again, uh, the test which was used to test the above hypothesis is the independent sample t-test. Given that the assumption of normality is fulfilled in case if normality assumption is violated, we shall use man Watney U test. So the reason for the selection of these tests is that the grouping variable, which is also called the factor variable is a binary response assumption. Obviously normality is the top assumption. So let us check the normality assumption, how it's so. For this we go to analyze, descriptive, explore, select the testing variable, that is number of blood. This is the dependent variable. In the plot section we need normality plots, histogram, statistics. Okay, descriptive, no problem. Just press OK. We shall check the test for normality, that is Shapiro Wilk test. Here you can see that number of blood tests year at the first year. When we check for the Shapiro Wilk, the statistics is 0.033, degree of freedom is 998, significance value is zero point 0.00, which is less than 0.05. So it is the violation of assumption of normality. Same as the histogram. If you see the shape, it is just uh, just one peak. There is no symmetrical shape. So obviously the normality assumption is violated. So we're going to use the man Whitney U test instead of independent sample t test. We may say the assumption of normality is violated, um, tested by Shapiro Wilk test. W statistics, which is the statistics, um, is 0.03, W is equals to 0.033. Always in the APS style, degree of freedom should come here. It's 998, 998, and the p value is less than 0.05. So we have to make italic the abbreviations always. Okay. So normality assumption is violated. So to what we're going to do is, for the result we shall use the Mann-Whitney test. Okay. So for the Mann-Whitney test, again go to SPSS, analyze, non-parametric legacy dialog, two independent sample t-test, Mann-Whitney. Okay, number of blood, and the grouping variables commodity as 0 and 1. So from where we get this 0 and 1? We got this, basically we got this from the value labels. We check for commodity, we can see at 0 and 1. So these are the definition of the group. 0 means no, 1 means yes, and then press OK. So here is the output result for Mann-Whitney U test. The test statistics is this, and asymptotic significant total. This is basically okay. This is Mann-Whitney U test. Its value, test statistics value is this. Z statistics is this one, and the p value is 0.005. It suggests that the test result indicated a significant result, and then bracket Mann-Whitney U test U is equals to U. There is no degree of freedom given. 299. Copy it and paste. You can paste it here. Up to 2 decimal points always in APS style. Remember that. And z is equals to this one. Sorry. Z equals to this, and p is less than 0.05. So why it's significant? Because the p value is less than 0.05. Is the result is significant, so it can be concluded that there are enough evidences to reject the null hypothesis and hypothesis. Summary, your conclusion, whatever you say. Summary. At summary, we can say that number of blood test result vary significantly for the patients having comorbidity morbidity comorbidity compared to the patients who are without comorbidity on average. So this is how we complete the assignment. And what is the meaning of every statistics? I hope you learned. In case any question, query regarding this, or you have a specific assignment question, please comment in the below section. I will solve for you. I will guide for you. Thank you. Thanks for watching. See you in the next video.